With the increasing of global warming and the massive using of fossil fuel, humanity needs to find a new sustainable fuel to replace the using of fossil fuel. Hydrogen, the most extending gas on Earth, has attracted the attention of scientists. The probability of replacing fossil fuel with hydrogen has become a topic of discussion among scientists from various countries. In the fuel cycle, greenhouse gas emissions are generated in three areas: production, transport, and use. And the process is referred to as the well-to-wall fuel cycle. Through the process of making hydrogen, hydrogen is classified as green hydrogen, blue hydrogen, and green hydrogen. The classification of the color depends mainly on the greenhouse gas emissions produced during the production of hydrogen. Among them, green hydrogen has the highest greenhouse gas emissions, and green hydrogen has the lowest greenhouse gas emissions. The graph shows the fossil fuel of gasoline and hydrogen during wall-to-wall process. Although the carbon emissions are zero when solar GH2 is used as a fuel. However, disposable energy is still used during wall-to-wall transport, but its energy consumption is still low compared to gasoline and SMR-GH2 or SMR-LH2. The graph shows the greenhouse gas emission of wall-to-wall. Neither green hydrogen nor green hydrogen produce greenhouse gas during use. Compare the 293 gram per mil and 276 gram per mil for gasoline. Hydrogen energy is truly zero carbon emissions during operation. Compared to total greenhouse gas emission, green hydrogen emits 16% less greenhouse gas than gasoline. Green hydrogen emits 88% less greenhouse gas. In summary, hydrogen has significantly lower greenhouse gas emissions than fossil fuel, both in the combustion process and in the pre-transportation of hydrogen. Therefore, hydrogen is significantly better than fossil fuel in terms of controlling greenhouse gas emission.
A hydrogen fuel cell consists of two chambers, but are connected to a tank of oxygen and hydrogen gas. The chambers are connected by a separating section of an electrolyte that allows for the flow of ions through the chamber, producing an electric current and thus energy that can be used. The reaction also produces steam that is then expelled from the system. Energy from hydrogen fuel cells are currently being used to power homes via power lines. Hydrogen is also being considered for use in electric cars. However, due to the high cost of running the cell and the dangers that come from it, such as explosion risk and the required pressures to contain the gas, hydrogen is not at the moment a viable fuel to use for electric cars.
The topic of hydrogen fuel efficiency in comparison to fossil fuels is of great interest in the current global climate. As the world continues to seek sustainable energy solutions, it is imperative to consider alternatives to traditional fossil fuels. Hydrogen fuel has emerged as a possible energy source that has captured significant attention due to its environmental benefits. One major aspect of hydrogen fuel that sets it apart from traditional fossil fuels is its efficiency. Hydrogen fuel provides small energy density per unit weight, making it an attractive option for both transportation and energy storage. Additionally, when combusted, hydrogen produces only water vapor, which eliminates greenhouse gases emissions, making it an environmentally friendly choice that aligns with carbon neutrality goals. It is crucial to acknowledge the challenges associated with hydrogen fuel production, storage, and transportation. Currently, most hydrogen fuel is produced via fossil fuel-based processes, which raises concerns about its overall carbon footprint. Furthermore, infrastructure development for hydrogen adoption is still in its early stages, which may limit its accessibility and efficiency in certain regions. To assess the efficiency of hydrogen fuel comprehensively, it is essential to consider its entire life cycle, from production to utilization. There is ongoing research and technological development focused on improving hydrogen production methods, optimizing fuel cell technologies, and enhancing storage capabilities. These innovations aim to maximize the efficiency and viability of hydrogen fuels as a sustainable energy solution. In conclusion, while hydrogen fuel presents itself as a promising alternative to fossil fuels, further research and developments are necessary to improve its efficiency and address existing challenges. By investing in innovation and infrastructure, we can unlock the full potential of hydrogen fuel and contribute to a more sustainable future.
Hello, I will talk about the hydrogen fuel manufacturing compared to the fossil fuel. I will divide it into both sides. One is advantages and another one is drawbacks. Let me first introduce its advantages. The first point is environmental protection. It's obvious from the picture that hydrogen can be produced by the wind power, which is more environmentally compared with the exploitation of fossil fuels. And I want to talk about some of the drawbacks. First of all, is manufacturing dangerous. The constant pressure required for the production and transmission of hydrogen energy is quite dangerous. Secondly, hydrogen energy manufacturing requires a large site. According to Young et al., making hydrogen requires electrolyzers. Finally, according to Young et al., hydrogen energy costs more than fossil fuel. And the fossil fuels will change in the future. So the last part is about utilization and development prospects of hydrogen fuel.
Next, I will concern about the drawbacks of hydrogen fuels compared to fossil fuel, and it will be 3 points in storage, production cost, and environmental impact. In storage and transportation, hydrogen can be stored in two forms, gas or liquid. When storing hydrogen in gas, it is necessary to use of high pressure tanks with pressure in 350 bars to 700 bars. And in contrast, if it storage in liquid, it needs a extreme low temperature in negative 252 degrees. So extreme condition lead to safety issues during the transportation. In production costs, the production of hydrogen relies on two main methods: natural gases recombination and electrolysis of water. These two ways produce hydrogen with high energy requirement, and the efficiency of production is dependent on the source of electricity use. So the production cost of hydrogen fuels is higher than fossil fuels. The next will be environmental impact. Although hydrogen produces no emission during the use, but in the production process, it can be environmentally damaged. For example, producing hydrogen from the natural gases release carbon dioxide into the atmosphere, which will make climate change. Emission of gasoline and vehicles such as hydrocarbons are the major source of pollution, but hydrogen-powered fuel cell electric vehicles emit none of these harmful substances. So in conclusion, when it comes to comparison between hydrogen energy fuels and fossil fuel, we need to recognize advantage and disadvantage of each energy sources, and we need to consider factors such as sustainability and environmental protection, because we need a